So for this part, define the radian. Define the radian. Okay, so what is the meaning of radian? I just write down straight away. So it's in the notes actually. Okay, so here I write down, it is the angle subtended at the center of circle. Okay, this is the first point. By an arc equal in length to the radius of the circle. So that is the meaning of the radian. Okay, let us move on. Second part. A small mass is attached to a string. So as you can see here, this is the small mass. The mass is rotating about a fixed point P. P is the center of the circle at constant speed. Okay, move at constant speed. As shown in figure 1.1. Explain what is meant by the angular speed about point P of the mass. Angular speed. You know, in the notes they talk about angular velocity. Okay, they talk about angular velocity, where angular velocity is theta over t. And that is angular velocity. Then angular speed, right, is actually the similar idea. Okay, so you just need to put everything in scalar quantity only. So we can put it in this way. You can say rate of change of angle. Rate of change of angle. You don't say rate of change of angular displacement, then wrong already. Rate of change of angular displacement is angular velocity. You know, everything is in vector quantity in that way. So rate of change of angle swept by the string. When you say angle alone, then it is scalar quantity. When you say angular displacement, then it is vector quantity. So we have to put everything in scalar quantity. Okay, now let's move on. Part B. A horizontal flat plate is free to rotate about a vertical axis through its center, as shown in figure 1.2. A small mass m is placed on the plate, a distance d from the axis of rotations. So you can see the mass m is there. The speed of rotation of the plate is gradually increased from 0 until the mass is seen to slide off the plate. Okay, so imagine it is moving faster and faster. At the end, it slide off. Okay, so the maximum frictional force F between the plate and the mass is given by expression F equal to 0.72 omega. So where we take it in this way, the mark, or I mean the small mass over here, is going to have a motion in this way, which causes it to slide off. If the motion is outward, then the frictional force is this way. So the frictional force is here. F equal to 0.72 W. W is the weight. So that's the value for the frictional force. And yeah, where W is the weight of the mass M, the distance D is 0.35 cm. Is 35 cm. 35 cm. Determine the maximum number of revolutions of the plate per minute for the mass M to remain on the plate. Explain your working. Okay, so maximum number of revolution. Okay, that means the small object can remain of the plate if the frictional force can hold it, is big enough to hold it, then it will remain on the plate. So if it rotates too fast until the frictional force is not able to hold it anymore, then it will slide off. So in order to find the maximum number of revolution, you have to take the maximum frictional force. Maximum frictional force is this value. Is this value where you can see here? Maximum frictional force. 0.72 W. You know, F equal to mu R, right? Frictional force. This is the mu. 0.72 is the mu. R is the normal reaction, right? So it's hence the weight. Okay, the weight. So this is actually the maximum frictional force. Okay, let's come back to our statement here. When you want to find out the maximum number of revolution, then you have to use maximum frictional force. Maximum frictional force. So the maximum frictional force, you know, frictional force acts towards the center of circle. Okay, acts towards the center of circle, and hence it is centripetal force. So the maximum frictional force is equal to the centripetal force. So when we put everything to maximum, then you can count the maximum number of revolution per minute. Okay, so let's see how. So maximum frictional force is 0.72 W. Centripetal force is mr omega square. And we move on. The W is mg. Weight is mg. Mr omega square. So by doing so, we can cut the m away, the mass of the object. We can cut it away. And then 0.72. So the G here is 9.81. The R, the radius is D. And D is given as 35 cm, which is 0.35 meter. So omega square, unknown. So we have to find out omega. Okay, so we just work out these equations. So we get omega 4.492. 4.492 radian per second. So this is omega 4.492. But we are not looking for omega. No? Omega is angular velocity. Angular velocity. So we are looking for number of revolutions per minute. Number of revolutions per minute. So this omega gives us one information like this. In 1 second, it makes 4.492 radian. The object make 4.492 radian. So we are looking for 1 minute. Okay, let's see 1 minute. 1 minute means 60 seconds. 1 minute, which is 60 seconds. So since you times 60 to the left, so you have to times 60 to the right. You times 60 with 4.492. So we get 269.5 radian. Okay, so this is the radian in 1 minute. And you know, they are looking for number of revolution. So you know, 1 revolution is 2 pi. So imagine, 1 revolution is 2 pi. Is 2 pi. Yeah? So if you want to know how many revolution here, so you just need to divide by 2 pi. Okay, so divide by 2 pi equal to 269.5 over 2 pi revolution. Okay, so we divide by 2 pi. So we get 42.9. 42.9 revolution. Okay, so that is the answer. That is the answer. It makes 42.9 revolutions in 1 minute.